Hello everyone, welcome to lesson 44 of our GoLang course. In the last lesson, we covered methods. We saw that methods are very similar to functions. In this lesson, I want to compare methods with functions. So, let's get started. Let's see some differences and similarities between methods and functions. In Go, methods are associated with a particular type and defined using the receiver syntax which we saw in the last lesson. The method is called on the instance of the type. Functions, on the other hand, are standalone. They are not associated with any type. Functions are called directly without the need of type. If the signature, that is the parameters, and the return type of a method matches that of a function, you can use the method as if it was a function. This is particularly useful when you want to treat a method as a standalone function but still take advantage of the method's association with the type or the state stored on the type. That is, the fields defined on the type. Let us now see this with example. First, I'm going to create a calculator type, which is a struct, and add a method to it. So this here is a calculator struct. On it, I'm going to define a add method. So I'm going to use pointer receiver and create an add method that takes two values a and b, which are of type int, returning an int, and then inside it, we just return a plus b, which is a sum of a plus b. Next up, I'm going to create another function with the same signature. Please remember, this is a function, not a method. It has a similar signature as our add method on the calculator struct. In our example, it's essentially doing the same, but you could have a different business logic. Now, I'm going to create another function called arithmetic operation. So here, I created the arithmetic operation function, and the first parameter to the function is a function itself, which has a signature accepting parameters of int and int type and returning an int. We have two other parameters a and b of int type. Inside it, we call the function passed into arithmetic operation on a and b and return the result. Now we can do fmt println and then add function, pass in the value 10 and 15. Let's run our program to see the output. As expected, we got 25 printed to the console. Now, let's modify it and instead have arithmetic operation here, passing the add function and then 10 and 15. So, arithmetic operation is accepting the add function since the signature is same as that of f. Running the program again, you can see 25 printed to the console. Now, since add method on the calculator type has the same signature as the function here, we can use it in arithmetic operation. So I'm going to do C calculator and then C.add. As you can see, Go allows us to do that. And if I run the program, it should run fine. And as expected, we see 25 printed to the console. Just to revise, if the method type is same as the function type, we can use it instead of a function. Please note that we are calling it on the instance of calculator. Just like functions, methods can be assigned to variables and passed as argument to other functions. This allows flexibility in programming, enabling the dynamic use of methods based on certain conditions or requirements. Again, please note that the method you store in a variable needs to be called on an instance of a type. So, let's look at another example for the same. I'm just going to remove everything we added. Now, I'm going to create a printer type, which is a struct. This has no field since we are just using it for demonstration purposes. Then I create a method print. I'm going to use a pointer receiver. Inside the print method, I'm just taking in a message string or m and then printing it to the console using fmt.println. Now as I told you, you can save methods into variables. But first we need to initialize the printer. So I'm going to create an instance of printer and then I can do print function printer.print. I'm not going to call it but save it in a variable. Next, if we do print function which has the print method stored in it, we can pass a string and that should work as well. Let's try it out to get the output. Run the program and as expected, we see hello world printed to the console. Again revising it, we are just saving the method called on an instant in a variable and then using that variable to call the method. So this is something that you can also do with methods. Now let's get to method expression. A method expression is a way to refer a method as a function value without invoking it. It involves saving a method into a variable, and the first argument to the function will become the receiver when the method is eventually called. This allows you to use the method as a standalone function and pass it around your code. Here are a few examples. In the first example, I am storing the getDetails method in f1. Please note that I am calling the method on the type itself and not on an instance of it. Then, when needed, I can call f1 and the first argument to this is the receiver, that is, instance of a person. Similarly, here again f2 is rectangle.setLength, which is a method on the rectangle type. And when I want to use it, I use f2, which stores the method, and pass the first value or the receiver r, which is an instance of rectangle, and any value and the next argument. Let's see this with examples. Again, I'm going to delete everything we added in the last example. First, I'm going to create the type person and add a getDetails method. Here we have added the person struct with method getDetails. I'm not going to walk you through the example because we already saw that in the previous lesson. Next up, I'm going to add another type, rectangle, which we used in the previous lesson as well. So here you have two types, person and rectangle, each with one method, getDetails and setLength. Now let's write our main function. Inside it, I can do f1 and then on the type person I can store the method getDetails in the variable f1. Please note I am calling the getDetails on the type directly and not on an instance of it. Next up, I can create an instance of person, p person, name Alice and age 30. Now I have an instance of person. To use the method expression, what I can do is f1 and then first pass the instance or the receiver, which is p in our case. Since getDetails doesn't accept any parameters, we don't need to pass anything here. Now, if I run the program, we should see the details of the person printed to the console. Go run main.go. Sorry, I actually forgot to print that to the console. So I'm going to do fmt println and inside it f1 passing the receiver. Let's run our program again to see the output. And as you can see, the details are printed to the console. So this is essentially a method expression where you save the method of the type in a variable and then call it, passing the receiver of that type, which in our case is p. We can do a similar thing with rectangle as well. Now here, I'm saving the setLength method into f2. Please note, since this accepts a pointer receiver, I have to typecast it. And then I create an instance of rectangle, after which I use f2 to set the length of rectangle to 1. First, I need to pass the receiver, which is r in our case, and then the length. Then I print the length. We should see the output 1 printed to the console. And as such, 1 is printed to the console. So just to revise, in these examples, f1 is a method expression for getDetails method of person and f2 is a method expression for setLength method of rectangle. When you later call these functions, that is f1 and f2, the first argument you pass will act as the receiver to the method. Let's now summarize whatever we have learned in this lesson. We learned that in Go, methods are associated with a specific type. They are functions that operate on instances of a particular type, or the receiver. Methods are defined within the scope of a type and can access and modify the data on the type if it has a pointer receiver. Functions, on the other hand, are standalone units of behavior that are not tied to any specific type. They can be defined independently of types and can be called from anywhere in the code. Since methods are functions with additional receiver parameter, they can be used whenever a function with a matching signature is expected. If the signature of the method matches that of a function type, you can use method as it were a function. But as we saw in the example, you need to call it on the instance of the type. That's it for the lesson. I hope you enjoyed it. Please feel free to ask any questions you may have by commenting under the video or reaching out to the Discord server. I will see you in the next lesson. Happy coding!